this lecture, we are going to solve a problem on flywheel. In this problem, the turning moment equation of flywheel will be given. So we need to draw a turning moment diagram using that turning moment equation. Then we need to find the total work done by flywheel using that turning moment diagram as well as turning moment equation. Then we need to find the angle. Here the angle theta represent a point where the turning moment and the mean turning moment meet. Then we need to find change in energy del E. Then we need to find moment of inertia of flywheel. Then we have to find out excess torque at 45 degree. Then using the excess torque at 45 degree, we have to find out the angular acceleration of the flywheel. Let us see one by one. The turning moment curve for an engine is represented by an equation 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta. In the previous problems, there is a diagram or a given data which is used to represent the turning moment diagram, whereas here the actual equation of the turning moment diagram will be given. Here theta is an angle moved by a crank from the inner dead center. If the resisting torque is constant, find the first subdivision. We need to calculate power developed by the engine. So this is the turning moment equation, given turning moment equation. Then subdivision 2, if the total fluctuation of the speed is not to exceed 1% of the mean speed, which is 180 rpm. So the mean speed n equal to 180 rpm, that is also given. So if n is equal to 180 rpm means we can find omega. So omega equal to 2 pi n by 60. So 2 pi multiplied by 180 divided by 60, you will get 18.85 radian per second. So that is a value of omega. So here that fluctuation of speed, so fluctuation means change in speed, omega 1 minus omega 2. So we can write it like this: omega 1 minus omega 2 is not to exceed 1% of mean speed. 1% I can write it as 0.01 multiplied by mean speed. So the fluctuations of speed is not to exceed 0.01% of mean speed. So this is a given data. For that n equal to 180 rpm. Now I can rearrange this equation like this: omega 1 minus omega 2 divided by omega. I can remove this, so which is nothing but 0.01. So omega 1 minus omega 2 divided by omega is nothing but Cs. So Cs also given. Then the third subdivision, angular acceleration of the flywheel, alpha, when the crank angle turned 45 degree. So I need to find out alpha at 45 degree, angular acceleration of the flywheel when theta equal to 45 degree. So these are the parameters I need to find out for this problem. Let me draw the turning moment diagram of this problem. X-axis represent crank angle, y-axis represent turning moment. So what will happen when theta equal to 0? So that is very important. So this is 20,000. So this 20,000 is this point. So this we can take it as 20,000. Okay, so the starting value will be less than 20,000. So that is a point. So for example, when theta equal to 0 means this is 0. So sin 0, total term 0. Then cos 0, 1. So this should be 1. So you will get 20,000 minus 5,700. So it should be 14,300. So this is a value of 14,300. 300. So this is 20,000. So the curve will go like this. So that's why we are drawing a curve like this. Only starting point we need to identify. So the starting point negative value, then it will go towards positive value, then it will reach a maximum somewhere here, then again it will come down. So we can easily draw a churning moment diagram for this problem. So now I am going to solve subdivision 1, that is moment of inertia of flywheel. For that, first I have to find out total work done by the engine. So the work done per revolution equal to torque into theta, whereas here the torque will be given in the form of equation. So this is the equation. If you have any doubt about this diagram, you just apply theta value, you will get a curve similar to this one. So what is the actual formula for work done? We need to add all the torque with respect to theta. So that is the point of work done. So addition is nothing but integration. So we are integrating with respect to minimum and maximum crank angle. Minimum crank angle 0, maximum crank angle for an engine 2 pi. So 0 to 2 pi t d theta. So 0 to 2 pi. So what is the value of t? 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta d theta. So this is nothing but addition of all the torque between 0 to 2 pi. So which will give you the total area of the curve, total area below this curve. So this region and this region and in this region. So if you add all those region, that is equivalent to work done by revolution. So now integrate 20,000. So you will get 20,000 theta, 9,500 constant, the integration of sin 2 theta minus cos 2 theta divided by 2. So here I have minus. Then minus 5,700 integration of cos 2 theta sin 2 theta divided by 2. So you will get sin 2 theta divided by 2. So there is no sign here. So we already have minus, so we keep that minus here. Then the minimum and maximum range are 0 to 2 pi. So first apply 2 pi. So first 2 pi. So 20,000 into 2 pi minus cos 2 pi 1. So I can keep it as 9,500 divided by 2. Then sin 2 pi equal to 0. So that third term equal to 0 minus then 0 term 20,000 into 0 0. So there is no need for that term. Then cos 0 1. So 9,500 divided by 2. So already there is a minus sign, so we can keep that minus sign. Then minus sin 0, this is totally 0. So minus into minus plus, so this is 9,500 divided by 2, whereas here 9,500 divided by 2 minus. So I can cancel these two terms. So totally you have only 40,000 pi. So this is the total work done by flywheel. So 40,000 pi. Next we are going to calculate the T mean. So we already know work done. So work done equal to T mean into 2 pi. So we need T mean. So T mean equal to work done divided by 2 pi. So what is the work done? 40,000. So 40,000 pi divided by 2 pi. So we can cancel pi on both sides. So you will get 20,000 Newton meter. So 20,000 Newton meter is nothing but mean resisting torque of flywheel. I mean T mean. Now power developed by engine. So this is a subdivision 1. So in the subdivision 1 we need to find out power. So power equal to T into omega. I mean T mean into omega. So T mean 20,000, omega already given. So n given, from that we can calculate omega. We already have omega in the given data 18.85, so you will get 377 kilowatt. So that is a power developed by engine. So this is the answer for subdivision 1. Power developed by engine is equal to 377 kilowatt. Now we will take the same turning moment diagram. It starts from negative, then it will reach the T mean value, then it will move upward. So next our aim is to find out del E. So del E means change in energy. So this is the top portion. So this is where the actual change in energy takes place. But the problem is, to find out del E, we need this value. So these are the two. So starting point 0 we know that, end point 360 degree we know that, but this value we need to find. So how do you find that value? So there is a condition to find this value. So what is that condition? So look at this point. What will happen at this point? You look at this point. At this point, this is T and this is T mean. T less than T mean. So gradually T will increase. So what will happen at this point? Both T and T mean equal. After this point, the T will increase, keep on increase, and it will reach a maximum value here. Then again it will come down. Then finally it will reach T mean at this point. So we need to find B and D. So this is nothing but theta B and theta D. So how do you find theta B and theta D? There is a condition, T equal to T mean. So at theta B and theta D, T equal to T mean. So look at this point, both T mean are equal. So this is a condition. So we already know the value of T in the form of equation, T mean equal to 377 kilowatt. So equate these two parameters. T mean equal to 20,000. So one side we have 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta. This is a given equation T. Then another side we have 20,000 Newton meter. Now reduce this equation. We can cancel these two terms on both sides. So it will be reduced as 9,500 sin 2 theta equal to 5,700 cos 2 theta. Again, we can keep sin 2 theta by cos 2 theta as tan 2 theta. So tan 2 theta equal to 5,700 divided by 9,500. So 2 theta equal to, from that 2 theta equal to tan inverse of this value. So you will get 31 degree. So 2 theta equal to 31 degree, theta equal to 15.5 degree. So this is a value of theta B, 15.5 degree. Now I need to find out theta D. So where is theta D? Since it is a sine or cos angle, so it may be a sine angle or cos angle. Both sine and cos angle will repeat the same pattern after 90 degree. Okay, so add 90 degree to theta B. So you will get theta D. Okay, so theta D equal to 90 degree plus 15.5, because in this equation we have only sine and cos pattern. Both sine and cos will repeat after 90 degree. That we know that, okay, from the sine table or cos table. So we can add plus 90 degree to find out theta D. So theta D equal to this value, 105.5 degree. So now we know both theta B and theta D value. Now we can integrate T. So this is T with respect to theta B and theta D to find del E. So del E equal to integration of theta B to theta D, only the top hatched portion. So that hatched portion is, so here we have a hatched portion. So this hatched portion is nothing but T minus T mean. So this is T mean and this is T. So I need only this hatched portion. So that is nothing but T by T mean. So take T by T mean of d theta. So now apply all those values. So theta b 15.5 degree, theta d 105.5 degree, again T mean 20,000, sin 2 theta minus cos 2 theta minus 20,000. I can cancel this term. Then the remaining 9,500. So integration of sin 2 theta cos 2 theta divided by 2. So sin 2 theta minus cos 2 theta by 2. So you will get a minus sign here. Again integration of cos 2 theta sin 2 theta divided by 2. So already we have minus sign. So 5,700 sin 2 theta divided by 2. Now apply 15.5 degree and 105 degree on this value. You will get 11,078 Newton meter. So this is nothing but del E, total change in energy in flywheel. So we know that del E equal to I omega squared CS. We need to find I value, omega given 18.85, CS also known value, I think 0.04. So when you apply all those parameters, you will get I value. So I equal to 3,121 kilogram meter. So this is the moment of inertia of given flywheel. This is an answer for subdivision 2. Next we are moving on to subdivision 3. For subdivision 3, first we need to find Txs. Txs already known. So this is a Txs. T minus T mean. So 20,000. Let me erase this. So 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta minus 20,000. So I can cancel this. So this is a value of Txs. So now we need Txs at 45 degree. So apply theta as 45 degree. So what will happen? Theta equal to 45 degree, 9,500 multiplied by sine 2 into 45 degree, 90 degree minus 5,700 cos 2 multiplied by 45 degree, cos 90 degree. So cos 90 is 0. So this will be cancelled. Sin 91. So Txs at 45 degree equal to 9,500 Newton meter. Now the excess torque Txs equal to I alpha. We need alpha value. So I already known. So alpha equal to T by I. So T excess torque. So this is excess 9,500 divided by I value. So I value 3,121. So this is the value of alpha you will get finally. The unit for alpha, radian per second square. So this is how you can solve a problem related to flywheel, in which the turning moment equation of a turning moment diagram will be given. Don't forget to post your questions in the comment box. You can also mention the topics which you expect from my channel. Subscribe my channel and like my video to support my video lecture.